Finally, let's discuss the third pillar that holds the whole Unix world: files. To simplify the work of users who are not familiar to working with the command line, the number of free file manager interfaces, like, for example, Midnight Commander, MC reminiscent of Norton Commander, or graphical file manager, more or less looks like Windows Explorer. But we'll see how we can work with files and directories from the command line interface or scripts. First, let's take a look at some of the symbols that have a special meaning in the file path. Backslash, it's a root directory and directory separator. Dot, it's a current directory. 2 dots means a parent directory. And tilde means a home directory. As we can see, Unix uses a slash as the directory separator, and Windows uses a backslash. This is interesting because early versions of Microsoft's MS-DOS operating system did not support subdirectories, just because it was a clone of CP/M operating system from Digital Research. It was a small operating system for 8-bit microcomputers without disk storage or with small floppy disks. Usually there were only a few dozen files on a floppy disk, and only a flat file systems with one directory per file system was supported. And at first, Microsoft MS-DOS operating systems didn't support subdirectories. Only when developing its own multi-user operating system, the Xenix, based on Unix, Microsoft implemented a hierarchical file system and ported it to a single-user MS-DOS. But at that point, the forward slash was already taken. It was used as a standard CP/M command option marker, like a dash in Unix commands. And Microsoft chose a backslash as a directory marker. Okay. As we remember, we have a hierarchical file system with a single root directory. And for newbies, this file system hierarchy can seem too complex. They say, when we install some software on Windows, we have separate directories for each product, and it's too easy for us to find something. But on your system, we don't know where we can find anything. But actually, in Unix-like systems, we have a very clear and stable standard for file system hierarchy, which is reflected, for example, by corresponding Linux specification file hierarchy standard. In fact, we have three main levels with repeating directory structure. At the first level, we have directories like this. We have directory bin with essential command binaries. We have a boot with the files for boot. We have for the bootloader. We have dev for device files. We have etc. The host specific system configuration files placed here. We have lib for system shared libraries and kernel modules. We have media and MNT directories for mount points of something. We have opt. Actually, it's analog of products in Microsoft systems. In this directory, we can see third-party programs installed in our system. As been essential system administrator binaries, TMP directory for temporary files, USR, the secondary hierarchy, and var directory for variable data. And finally, root and home. Home directories for root superuser and other users. In the USR and USR local directories, we see again the similar directories. As I said, devices in Unix-like systems look like files, but the special files placed in a special directory, dev. For example, devnull, which works on write, discarding all and on write operation reports, just reports succeed. During the read, just return end of file. Dev0 works like devnull to write, but on read returns only null characters. We may use this file as a generator of zeros. Devmem, it's just the RAM of our computer. Dev TTY terminal lines, dev SD, it's just our hard disks. And usually each such file is just a rabbit hole in the operating system kernel. When working with a pseudo file on this directory, we see this device as a stream of bytes and work with it as with a regular file. More information you can find in under the hood lecture about device drivers. We may also have many other secret paths to the kernel internals, such as proc and sys directories. For example, we can see the information about processor in our computer, including hardware bugs. Memory usage information, including swap space and even interrupts.